Firstly, I welcome everybody to this third class of ours, and this our class is basically on multimeter. Yeah, most likely we will not be using much time. Firstly, whenever we are talking about multimeter for motherboard, we have basically two types of motherboard. One is analog and the other one is digital multimeter. Firstly, we are all familiar with multimeter, anything analog and meter, anything analog and digital, we are all familiar with it. The analog of a thing is always in form of this, and it will have a kind of line that will range to the amount of value you are checking. And the other one we have is the digital one. In this digital multimeter, this digital multimeter is the one that outfaces the normal analog we are using before. And many times some people will be claiming they know how to use analog much more than digital. Actually, this is because let me say the person is still a learner, because digital is much more advantageous than analog. Why is it advantageous? Because with digital you have the exact value of what we are checking. Because you will not be confused that is this voltage complete or not. So that's the advantage of digital over analog. For the sake of this class, I'll place more attention on digital multimeter, so we won't talk about analog multimeter. Don't be offended for this picture, I just snapped one of our meter, but the main point is just get the message. We should look at this first picture here, this one. You can see I don't place any probe here, so that you guys can fully clearly see what is written on it. Firstly here, and secondly here. This can be a bit complicated, but they are all the same thing. The best thing I will do now is I'll open another meter and see and show you something else. Look at this meter here. The probe has been placed there based on the polarity, but the easiest way, if you look at this multimeter here, what we have here is COM. This is more or less like common parts, and we should look here. We have different type of symbol, and what are those symbols we have here? Firstly here we have capacitor to test capacitance. Secondly, we have continuity symbol to test continuity. And followed by this particular symbol, which is called diode, to check diode value, basically impedance as well. And this one here we have ohms, that is used to check resistance value, so resistors. And finally we have voltage here. This V is for measuring voltage. That is, if we are to check all these value here, then this is where we will have our probe. If we are to check voltage, resistance, capacitance, continuity, diode, we will have our probe here, and this will be our normal ground. Another point here is we have different type of multimeter. We have, digital as well. We have auto ranging and manual ranging meter. Whenever we are talking about auto ranging, we are talking about those meter that we want to check any value on them. Like you want to check value of components. Well, let me open another one. I want to open auto ranging. This is manual ranging. Let me go for this. We should look at this diagram. The same thing goes with this. So I want to align this properly for better understanding. So here, if you should check here, we have the same thing I've sketched earlier on here. So therefore, this will be my red probe. That is, whenever we are talking about our red probe, we are talking about positive parts. And the other one we have here is our ground root, that is common, just like the first one. This also will be ground, which means in this one, if I'm to place probe, I'll place this back probe will be placed here, and the other red probe will be placed here, just like I've have it here. So they will do the same function here. What is the determinant to know auto and manual ranging multimeter? If you should check this one, you will notice if they talk about voltage here, DC voltage, here we have different range of voltage here. Actually, it is not different voltage, we have different amount of voltage. Basically, this is 200 millivolts, this is 2000 millivolts, this is 20 volts, this is 200 volts. If I'm to check anything above 200, then I'll place my meter. I'll range it after 200. For instance, if I want to check like 25 volts now, and I know, okay, I'm expecting 25 volts at this point. So if I should place my probe, if I should range my meter, let me use another color here, so that it will pass message. If I should range this meter here, that is 20, because this place can only read maximum of 20. So the thing I will get here is 0, 0, 0, because it's above the 20 volt I have here. But if I'm to check anything above 20, like that 25 volt I've just said now, I'll place the meter as 200, because 200 is higher than 25 volt I'm expecting. Then at this, if I should range this my meter at 200 here. Sorry, yeah, I want to check 25 volts. Let me see. So I want to check the same 25 volts. If I should tune my meter to 200 here, automatically I'll have 25 volts here. So that is it about this section. 25 volt, not 2. 25 volt. Why we are calling it auto ranging is because if I'm using this particular meter for the same thing, once I've punched my voltage range, this is my voltage symbol. Whenever we're talking about voltage symbol, it will look like this V and a straight line and like a 3 dots under it. So that's the range of, that's the symbol of voltage. Straight line and these 3 dots here. That is the symbol for voltage on multimeter. And here, if I should, because this one is auto ranging, automatically, so far I have this on voltage range, no matter the amount of voltage I want to check, I'll just place it at voltage range. So if I'm checking the same 25 volts, once I have it on my voltage, I'll have my voltage at the screen. So far it is auto ranging without tuning the range I want. So that's for DC. The same thing goes for AC as well. Here, if I want to check AC as well, just like we've all known that what we are using in Nigeria is 220. If I should put the meter at 200 here and I want to check 220 volt AC, I can't have the value on my screen because this value I've set my meter here, I mean the tuner, the value I've set it here is lower to 220. so I won't have the voltage. Instead, if I'm to get it, I'll have to tune this probe to around 750 here. So if I'm to check here now, I'll have my voltage at this point, which is 220 volts. So that is it for that part. You will now understand that part. Anybody with clear mic can talk.
Ben sir, yes sir.
Okay. So now that's the difference between auto ranging and manual ranging multimeter, and that is how they use them. So now if we are to check value, the kind of component you are checking will determine where this voltage, where this meter will be ranged. So if I'm checking voltage, then I should know I have my meter range at the DC part. Let me take screenshots so that I'll cancel this and do something else. So whenever we are talking of checking any value on meter, the kind of component we want to check the value will determine where our meter will be ranged. Basically, all components have their own measurement. Whenever we are talking about voltage now, we measure voltage in volts. Whenever we are talking about resistor, we measure it in ohms. We have been familiar with ohms. Let me sketch a few things here so that you guys can understand better. Let me use black pen. If we are to check voltage, the range you have something like this in that range, in the range where we place your meter. If you are to check resistor, then we will have something like this, ohms. If you are checking capacitance value, although we don't really check capacitance value in motherboard repair, we don't really check it. Instead we check diode range. And we have to check diode too. This is where we place our meter, the value of, and this is where we range our meter. So this is for capacitor, this is R for resistor, and this is V for voltage. So basically these are those things we check on motherboard. This is why I said the component we are checking will determine where our meter will be ranged. I will refer back to what we did yesterday. One of those useful places in multimeter, one of the most useful places in multimeter when we are working is the diode range. So going back to the yesterday class, we were talking about there is voltage at all these points, blah blah blah. But one of those things we check when you collect board as for repair. Firstly, you need to know what is the condition of all this coil. What is the condition of standby coil? With what? With meter. What is the condition of RAM coil? With what? With multimeter. What is the condition of my auxiliary coil? With the same thing, multimeter. This auxiliary volt can be anything, but mostly it's always 1.8 volt. What is the condition of this coil? If I should check on multimeter as well. Which other one? What is the condition of this coil as well? If I should check on multimeter. This is the value here. This is the value I will get here. So how do I get this value? I'll explain them one after the other now. This is for CPU. So let me open one meter. Let me go with meter you guys will be familiar with. I'll go for auto ranging. Actually, I'll pick auto ranging because of this class, or manual ranging, sorry, because of this class. Auto ranging is always easier.
What will I do? Okay.
In this section, like I've said earlier on, I said we have different range in our multimeter. Firstly, the secrets in using multimeter on laptop motherboard. We know normally, or let me first explain voltage so you understand better. I will explain the normal one first and we'll go for the abnormal one next.
Okay. What machine?
Okay, what I'll do now is I'll screenshot this and I'll come back here again. I'm thinking of how to simplify this. Firstly, let's assume we have my adapter charger here. We all know that if I should have charger, I will have two wires there basically. Let's assume this is the charger here. So it will have basically a wire, and if you should open the wire, you have two different wires there, and one will be positive, the other one will be negative, which is ground. Basically the black one, let me change the color. Basically the black one is always the negative and the red one is always the positive. There are some times whereby you have the positive inside and the negative will be the positive will be surrounded with the negative, and that other positive one is always folded with white insulator. Then you have the black, which happens to be the aluminium, that will be folded around the white insulator to be the negative part. So if we are to check voltage, firstly we all know that charger should supply 19 volts basically. Some can be 20, 18.5, but let's just go for 19, even 15. Let's go for 19. So to check that voltage, firstly I'll tune my probe to the range where I know my charger will fall in. Now if I'm checking 19, I can still tune it to 20. Then I'll connect my positive to positive terminal of the charger and negative to the negative terminal of the charger. If I have to check in this way, if this charger is good, I will have 19 volts at this point. Let me use black here. I'll have 19 volts here. Where would I have the 19 volt? I will get my 19 volt on the multimeter screen. So this is the setting here. That is black for black, red for red. That is what we use in checking value. So that is it for that section. So now if I should go back to where we were working yesterday, when I said we have some voltage, we have some voltages at the coils. Yeah, why is it that we are placing more attention on this coil on motherboard? The major function of all this coil here, first, whenever we are talking about coil or inductor, anything I have on this inductor here will give me, or let me say like this, inductor is a good testing point for repair. If I should place my meter at the inductor here, so whatever I get at this inductor will summarize the status of this section for me, whether I'm checking the impedance or voltage. So if I place my meter there, this will summarize for me what's going on in this section. The same thing go with this standby section as well. So the conclusion of all this section is at this coil. So therefore inductor is a good testing point. So now if I want to check voltage, what I'll do is I want to show you ground on a motherboard. This camera is not working. Actually, I'm using the demo version. Unfortunately, I can't use this camera. I wanted to zoom my screen. This can't go beyond this. Well, let me leave that part. Let me go for another board. I want to show you guys common ground. So whenever we are talking about ground, mostly PCB on its own, it needs ground supply. Like whenever we are talking about electricity, we're talking about positive. Notwithstanding, it needs that negative because it needs that negative to work. So whenever we are talking about ground, there is always enough ground on motherboard. All these parts here, they are ground. So I can connect my meter on any one of them. If I need ground, or if I want to place my black on ground, I can use any of these. So ground is everywhere on the motherboard. So whenever we're talking about ground, there are some components that have polarity. Whereby we have those ones that have polarity, positive and negative. The other parts that happens to be the ground pin is always connected to the negative pin is always connected to the ground. Like this component now, this is the ground and this is the positive. So as for voltage, I will explain them one after the other. So going back to the image I was using to illustrate initially. So if I should say we are checking all these voltages, what we are actually checking there is the value. And if we want to check officially, we will place our ground to ground, that is negative to ground and positive to supply. For the sake of this class, we will assume every part of this image here is ground. So if I'm to check this value here, I will connect my ground. I will connect my ground to the PCB. Or let me use straight line. This probe here will be connected to ground. Let's assume this is the ground part of the board, and I want to check the value. So the positive will be connected to the coil itself. So if this is connected properly, so whatever I'm expecting this voltage is, as far as voltage is concerned, so that is what I will get on my multimeter screen. Let me change this to okay. So as per voltage level, whatever I'm expecting is what I will get on the screen of my multimeter. So this is the value I will have on my multimeter. So another one again, let me delete this so that I'll use red. That we pass a message that this is red, positive signal. So that's clear. The same thing goes with this section as well. If I should check my value here, so all this value, that is where I will have my probe. All this value we are talking about as for voltage. So the values I will get there are those values we mentioned earlier on before, and this one as well.
Value on Abani meter. 1.05 value.
This value here, why the value is not fixed is because I've explained in the previous slide, and this one is 0.7 to 1.7. If you are working on motherboard and this coil have supply, if this processor should get heated beyond the given degree, this board will shut down. We normally have some component there that we call thermistor that they will sense the amount of heat on this chipset. Once they discover this heat is getting too much, they will shut down the system. There is something we call thermal shutdown. So it triggers turn off when the board is getting too heated. But because there is no heat sink there that will transmit that heat to the thermistor, the processor will continue to generate heat even beyond the specified level, and the next thing that will happen is the processor will die. And if the processor is gone, there is nothing you can do than to change it. So conclusively, whenever we are troubleshooting board, once the CPU voltage is generated, we need to add in our heat sink and cooling fan so that we save the CPU. So going back to the class, for the rest as well, where do we have the value? We get them on the multimeter. And if we are to get this value on multimeter, you wouldn't have negative signal, you have it straight up. Like now, if I'm to get 1.05, I'll get exactly 1.05, not minus 1.05. Why is it like that? Because the probe is connected in form of positive for positive, so we wouldn't have negative value. If it is RAM, it's going to be 1.5. If it is CPU, it's going to be 3 volt or 5 volt without any negative signal. But in a situation whereby you see me reverse, or let me say you see us checking board and you are getting minus plus the value, this is trying to tell me we've reversed the multimeter. That is, you have something like when you have minus like this and we have the exact voltage here. That will happen because we've reversed it by placing the positive probe to the ground and negative probe to the supply. So whenever we are getting the value, we are going to get minus here. Doesn't mean anything, but why I've actually mentioned this is because the next thing I'll be explaining now will be somehow connected to this. So now we've specified that if we are checking voltage, we said positive to positive, negative to negative to check voltage. But if we should reverse it, it doesn't mean anything. The only implication is just that you have minus signal behind whatever you are getting, before whatever you are getting. So if you are holding your meter and you don't know where to place your positive and red, at least you'll be sure of your charger that the outer part is negative and the inner part is the positive. So if I should place my black probe at the part where I'm sure is the negative, which is the outside metal, and I place my red probe inside, which I'm sure is the positive, and I'm getting negative value, this means I've interchanged this wire, this probe at this point. But if I'm getting exact voltage without minus, it means my probe is properly connected. So that is it for that section. I'll screenshot this and I will log out. So in the next 1 minute I'll come back. So I'll just do that so that I'll wait for the rest for 1 minute, then we'll continue. It's almost time. We have 1 minute left. Yeah, you can see 1 minute. If you are using, this is just a free class and everything we are using here. It's a low budget class though. but the main point is at least get the message. So I'm waiting for the rest to join, because this part is one of those crucial part of the repair. Well, let me say secret of one of those secret of repair. I'll drop it here. Actually waiting for the rest.
Honestly. Okay.
So those that have metal and working board can use that avenue to check one or two things. So that's question. So I'll carefully treat everything one after the other. So now, whenever we are checking voltage on motherboard, your charger must be connected. So voltage and current are the basic thing we check with charger. Voltage and charger. Every other thing will be checked off charger. Or for simplicity, let me say it like this. Only if we are checking voltage is when we use charger. And that is it for that. So the next important thing here is, I'll skip the rest for now. So let me go to the major thing now. The major thing we have now again is the impedance value, that is diode range. There is one component we call diode. So after treating motherboard component, you guys will understand that part clearly. This component is a very, very wide topic and it's very, very interesting. In fact, it's the crest for almost other production of components, because at the beginning they produce diode. After diode, they upgraded it to transistor. And you know, when you are producing something, the first one, the subsequent one is always improved. So after transistor, they produce JFET. So it is this JFET technology again that is being used to upgrade, that is upgraded to produce MOSFET. So MOSFET was upgraded to IC was upgraded to IO. Once IO2, the idea of the IO2 is upgraded to produce chipsets. So, and for the chipset as well, to produce CPU. So their crest is this diode. That is why this diode is very, very important whenever we are talking about component. This particular component is a component that allows voltage to pass through one part and does not allow the voltage to pass the other part. So that is one way direction. So if, for instance, voltage is coming from this part, the diode will allow the voltage to pass through. But if the same 10 volts is coming from this part to this part, this diode will not allow, because this part will block it. Even though if this one is going to allow this to pass, it will draw some amount of voltage, but for basic understanding, let's just understand it will allow the voltage to pass. But if it is coming in reverse manner, the diode will not allow the voltage. So the diode itself, it has the positive part and the anode side, that is anode and cathode side. Now we are talking about the positive side of this diode, and this is the negative side, and this is the positive side of the diode. So in this diode, this is it here, this is the diode here. So I can just redraw it here. He said this is the positive part. Let me use ink here. Let me scratch this. like I said, this is the negative part. So if you are to check the value, you range this meter to the diode. Let me use another pen. You range this meter to the diode range here. Okay, so after ranging this to diode range, you place your probe according to the polarity of the component, that is positive for positive and negative for negative. Here you have value on the multimeter. But normally we call this forward bias, FRW, forward bias. I said bias, forward bias. But if I should reverse this by interchanging this negative, this positive to negative and negative to positive, in this case you wouldn't have any value here. It's going to be zero value. That is, we reverse the voltage and the probe here. So we won't have any value here, and this is called reverse bias. Let me screenshot this. So now we should go onto the motherboard. Okay. If you go onto the motherboard, you used to have diode on motherboard, different type of diode. You have 2-leg diode, 3-leg diode. By the time we treat components or introduction to components, you understand better. Any components, any diode on the motherboard will be identified on the motherboard with the word D. So let me try and find the 2-leg diode instead of 3-leg. Like this one now, this is a diode. How do I know? This is PD4303. If I should check inside the schematic, PD4302. As you check on the schematic, it's going to be 2-in-1 diode because it has 3 legs here. I'll show you. This is it here. Normally it used to have 2 legs, but this is a bit complicated. Actually, not complicated. It's just let me say it has been upgraded here. Let me show you. This is PD4302. So this is it. We have 2 diodes. This is first one and second one. So nothing complicated. It's just 2 diodes, but it's just like the, let me say, upgrading. But the basic thing is this is just normal 2 diode. So this is the first one and this is the second one. So they are now packed in a box. That is why we have them in 3 legs. So this will be pin number 3, this will be pin number 1, and this will be pin number 2. That is pin number 3 and 1. They are 1 diode from here to here. That is 1 diode. Actually, this is a complex one of the diode, but I'm supposed to start from the crest. But I only just want you guys to understand what is this diode. And nothing complex though. You understand as we go on the motherboard. Why is this? What are we checking when we don't have the charger there with multimeter? What are we checking? We are actually checking the diode value of the board, as in the component. So if you check another component here, let me see. This is another component here. This is another component, JFET, and we also have diode here. That is why diode is very, very important for us to understand. This is another component here, MOSFET, and we have diode in it again. So it is very, very important. So mostly we are checking the value of all these components. We are checking the diode value. So how do we check all these diode value? If I want to check for instance, if I have a board and I want to check what is the condition of this board, let me show you one. Let me find an image for you guys. If I want to check the value of this coil, I would have set my meter to diode range, and wait, let me use blue pen. I will tune this meter to diode range because what I want to check diode range, that is impedance. And doing this, I don't need to insert charger. And here the only secret here is that we will have to reverse that polarity law, positive for positive and negative for negative. We will reverse it, replace our positive on the ground this time around. Here we have our positive here, and because if you check it, if you connect it properly, positive for positive, negative for negative, and I want to check the value, I won't get the value. But if I should reverse it by placing positive to ground, let me like this. If I have positive on the ground and I place my negative probe on the testing point, if I have my negative probe at the testing point, then I will get the expected value. And what is the value I'm to get? That is the value we have here. So if I'm checking RAM here, so if I'm checking the RAM section without inserting charger, so if I to check this value, if I should connect my meter like this on the motherboard, if I should have my meter like this placed on the motherboard, any value I'm getting on the screen, if it is above 0.040, theoretically the part is clear. That is, this part is okay above 40 theoretically. So I can cancel what I have here and use this arrow. And use green color. So if I have anything lower than 40 here, which means this section is 40 theoretically. There are many cases whereby this is what you have and it's going to work. So that is not complete short. Let me use green. So this value is what I'll have on my multimeter. Anything above 0.040, that is telling me that section is that RAM section is fine. The same thing also go for other section. All these values that are written here, let me use black. All these values that are written here, if it is standby section I'm working on, this standby section I'm working on, at least this coil I should have something above 0.100 as per impedance level. Which other one again do we have? CLR. This is the value for CLR. So at this CLR, if I want to confirm if this part is clear, I should have value above 120 on my multimeter. This auxiliary voltage as well, I should have above 100. For PCH, at least 0.15. Why this value is low is because these chipsets here, they are on board that are not removable. So if we have them on board and we are checking their value is always low because of this particular chipset we have on the board. And even this one as well, we are going to get around this value. Anything above this value is good theoretically, even practically in this section here. So and for the last part here, anything I have here, if it is less than, this place is not too clear, but the value I have here is around 0. Okay, let me explain. I'll use the same blue. here, if you check what I have here, you see I have P there. This with P means with processor. So if I have processor on it, if I have 0.05 upward, it's still fair. But once I've removed the processor, I'll be getting around 0.130, 150 and above. That should be fine as far as impedance is fine. So far I don't have the processor on it. So that is it for this section. With processor, this is what I will have with P. Without processor, at least I should have around here. Mostly at times if you have 0.32, basically all this one as for SOC. So that is it for this part. Let me sketch them out. The value I will get on my multimeter for standby section. So sorry, CLR section. This is it. Theoretically, at least it shouldn't be less than this. So theory is always slightly different from practical a bit. Some theory facts are not usually 100%, but it is the basic for you to understand whenever you are treating motherboard. So therefore, as per impedance level, all this value refers to all this thing we are checking refers to the impedance value. And don't forget, like I've said, the key thing here is we have to reverse the probe. That is, we have the positive on the ground and the negative at the testing point. So it's like someone said he has board with him there. So I want the person to practicalize what I'm taking now and let me know. So while the person is doing that, I'll continue with the class.
Only function section will RAM section.
Epic any coil case of value if you want. Tàbí tó bá yẹ pé tàbí. So this one is just direction. I'm telling him put your meter at diode and connect your probe just like I've explained here. While the person is doing that, let me take screenshots. E03, right?
Yes.
Section will let check.
Yes. RAM section.
RAM section. Check the confirm any schematic RAM section. Let's check.
Yeah, but me confirm.
So the person is trying to check and give me feedback here. So now he said he had 300 and something. I was doubting if he's actually checking RAM coil. But now the point is whether you're checking RAM coil or not RAM coil, if you are having impedance of 3 digits of around 300 and something, 100% that part is clear. What is the worst value to get when you are checking impedance? This is the case where you are having 0.02 or 3. This is a bad reading if you are getting 002 or 3 or 4 self, even 5 at times, even 5. So far it is not SOC. So these are referred to as shorts. So now this is professionally referred to as short. So when somebody is telling me my RAM section is shorting, I know what it means. When somebody is telling me my standby section is short, I know what the person is trying to communicate. And when the person is telling me, okay, I have this issue with standby and it's short, so I understand what he's trying to explain. So this CLR, if this CLR is short, if you should use generator, you will detect it on the charger because it will have on the generator. because it will affect the generator. So now, whenever the worst case we can get for this impedance is when we are getting lesser than the expected value here, and the most worst one is when you are having around 0.002, 0.003 for any section. So now if you should reverse the voltage, is what I'm trying to explain here. If you should reverse the probe, this is what you are going to be getting. So what this short is trying to tell us is God child and devil child, there is no part between the two of them, like there is no relationship. So
who are well clear?
So Nisi, we should check all this coil value. I'm telling the guy that is checking. You should check all this coil value. You can check and tell me the lowest value.
Okay.
Everybody knows in Tosin.
Ó wà tó tí mi ó náà mú rí lọ́wọ́.
No, ẹ máa sọ value tẹ bá ń bá bẹ́ẹ̀ fún alẹ́ ọkàn ká máa gbọ́ lẹ́sẹ̀kẹsẹ̀. À ń dà tí kò ń báyìí.
Ó máa 0.01.
0.01
1.
kò sí value kankan lẹ́yìn 1 ní àbí.
Kò sí value kankan lẹ́yìn.
Ibẹ̀ yẹn ní problem.
Okay.
Bí ṣe bá kọ ìlú bá jẹ́ mi fẹ́ mọ̀ ibẹ̀ yẹn ní problem. Tẹ bá download schematic ẹ̀ tẹ bá wo section tó jẹ́ so problem 1 section yẹn. Which other one?
The next one.
Ẹ̀tàn kámẹ́rà yìí.
Okay.
Tẹ́bà ti rí ìtàn yẹn fílẹ̀.
Mi mo bá ti mọ ọ̀rẹ́ o.
Ó yẹ ṣiṣẹ́ lọ ẹ continue mo ń gbọ́.
Okay, mo ti pè yẹn fún 163.9.
163.9.
Yes.
Value yẹn wà okay ní ìfẹ́ mọ section tó jẹ́ value yẹn wà okay. Tẹ́bà wo ibà yìí.
Ó ti padà arrive 16.4 báyìí o.
Kí lè ohun
16.4.
164 right?
16.4.
Ṣé voltage yẹn check àbí impedance?
Coil ni o, coil.
Ẹ̀mú bẹ́ẹ̀ bẹ́ ṣé voltage lẹ̀ check kí nọ́mbà bẹ́ẹ̀ kí nọ́mbà.
Okay, kí ni mo check this thing?
Impedance.
Diode mo gbé sí o.
Diode ẹ̀ máa gbé sí ẹ̀ máa yọ charger ẹ̀ check àwọn coil yẹn kẹ́yẹ́ ká gbọ́.
Charger la rẹ̀ kò sí charger ń bẹ̀.
Ó yá kí ni value ten get? Tẹ́ bá fẹ́ wait anyway. If you are checking this value here, you need to place your probe very well on this testing point. In fact, you need to make sure they are connecting with the RAM. But there are times on this component here, let's say this coil, there is always some flux there that won't let your probe act to the metal there whereby you get your voltage. So if you are checking, you have to make sure your probe is really touching that metal, else you won't get fixed voltage. Now let's continue.
173.4.
173. Okay, which other one?
Yes. The next one.
Like waste time while looking. Very pace. So we are wasting our time. I want to believe that section is clear to everybody. So we need to proceed. Are you hearing now?
Yes, sir.
So well.
Oh yeah,
I've explained the reason why the fluctuation is coming up. You have to place your probe very well on the testing point. So
Then the red here there one footage. Yes.
Lórí bọ́ọ̀lù nǹkan.
Lórí board black one ní ground.
That is what is mixing. The guy is
So red here there.
Red lè máa dé sí ground.
on testing point. That is
Red
why
point then the value yẹn ò lè.
that is the secret. You have to reverse it.
Sorry.
Ẹ̀yin ẹ ti Jones. Ẹ ti hard.
Yes.
So I won't waste our time much here. The guy is mixing some stuff up. Aside from that, so I'll carefully send the picture to the guy and he will continue. So without wasting our time, we'll proceed. So what are those things we check with diode range? Wherever we are expecting to get voltage and we are not getting the voltage, probably we have a board, and now I'm sure at the standby I should have 3 volts, or if I'm to check the impedance I shouldn't get anything less than 100 as per impedance level. So if I should get to the standby and I check the voltage and I'm getting 0 volts for the voltage, somebody is complaining about network. So let me confirm everything is fine here.
I'm going, sir.
Okay.
No, everything is fine. So at this part, if I should check just like I've directed, I place my negative to ground. Okay, I want to use diode range. If I place my positive to ground, or let me use red. If I place my positive to ground and I place my negative to supply, I know what I'm expecting to get at the CLR here. So if it happens that what I was supposed to get there, probably if I'm to get 100 and above, if I'm expecting 100 and above, that means good signal, and I'm getting around 0.10 or 20, 100%, this 19 volt part is faulty. So there is problem in this section. Whether I plug in charger or no charger, I've detected that fault already. But don't forget, I said I will tune my meter to diode range without plugging charger if I'm checking the impedance. So for now, without plugging charger, I've detected the fault. So if I'm getting 100 and above, I want to believe the part is clear, and this 0.010 is bad. This diode range is very, very important because diode range is very, very, very important because one of those functions of this diode range is, look at this component now, they have diode in them. Once there is problem, they will cut signal here. For instance, if you have problem in this CLR, it could be anywhere, but at this CLR you can easily detect at this CLR. So if there is problem with this CLR, so every other component connected to this CLR will be notifying you problem. So this part is what we call the part where they work together. So if one part is faulty, they will all be telling you they are faulty. So diode range is very, very important whenever we are checking voltage. Wherever I'm expecting voltage, if I should check and there is no voltage, the first thing I will do is I will check if the impedance is fine. So you have different case of short. You have 19 volt short, 3 volt short, or 1.1 volt short, all these small voltage short. So short could be anywhere. So I have a case now in my office. When the person brought HP folio, I will upload the case. The problem was short of 3 volts that was going to the SIU, and that was why the system was not turning on. So I'll show you later. So let me screenshot this. We can also use meter to check our resistance value. This resistance value, if you are not working on advanced level, you will not see any point or reason of using the resistance value. That is why when some heat and try engineer are working, they will need motherboard to confirm. They will need the same motherboard to confirm what is the value of some component like resistor. Once you check it on block A, you check on block C, sorry, block B, check on block A again, you confirm on block B. That is wrong because Adibin is using, he understands schematic, even though if the component is not there at all. If you have the schematic, you can easily identify which component is missing. So you can easily find it and place it there. So whenever we are talking about resistor, let me pick a board. Normally go for this image because this is color green and the image is always sharp. So this place is not too clear. For instance, look at these small ones. Despite, okay, let me go to the other side. Let me go to the standby section. If you should check here, this is standby IC, and what I'm seeing here is TPS 51125. This IC, I'm used to this IC. Pin number 16 of this IC. This is pin number 1, 6 by 6. This is 6 plus 6, making 12, 7, 8, 12, 13, 14, 15, 16. This is pin number 16 here. There is no resistor here. I'll leave this part. Let me go for another one. Actually, it will be behind the board. This is another resistor here. Or you should have it around here. But let me go for something else. Let me place this one side and I'll open the schematic. So I want to pick a resistor for instance. Resistance is always very small, but no matter, despite how small they are, they could cause any issue. The board might not power, it might not display, it might not charge. Especially when they come with some board and they tell you, we just open the board and close it back, and it happens that it's not working again. Most likely, these small ones must have been tampered and probably missing on the board. For instance, now look at these two capacitors now. These two capacitors, without them, board are never going to turn on. And look at the rest here. This one, even if they are missing, the board will on. This ceramic, this yellow ones here, this yellow ones here. But these two are very important. This and this, they are bootstrap capacitor. Going back to the resistor. Resistors are represented in this form. Something zigzag like this, resistor. What is resistor itself? This is components. For instance, when I have a big water tap like this, let me leave resistor topic here. So whenever we get to motherboard component, we'll talk about components a bit before going to the major thing. So the simple point here is this is resistor symbol here, and this resistor, it has no polarity, that is no positive and negative, and it has a lot of functions. It is used to protect board, to pass voltage, to drop voltage, and different functions. It is used to protect IC as well. We have different function of this resistor. So we should look at this resistor here now. Let me use another color here. That should be clear here. This is one resistor here. This is PR4611. PR4611. If I should come here and type it with multimeter, if this value is good, I will know. If this resistor is good, I will know. In schematic, let's check the value. PR4611. Okay, this is it here. This is resistor here. We should check on the motherboard. This symbol here, this is the symbol I've drew earlier on. And what is this resistor here? It will have its own value. This resistor here is a kind of 0 ohm resistor. Resistor whereby the value is very low, but yet it is still important for the board to work. Let me find another one that will be more glaring to you guys. I want to show you the one that the value will be properly written, like boldly written for you guys. The other one, that one is 0 ohms, but with time you get familiar. Let me go for something simple. You have PR4 system. Look at this value here. You have 2D2. This means this is the location. PR4 is 10, and this is the resistor here. Bootstrap resistor. You get to understand them one after the other. This is the resistor here. This is the value here, 2D2, that is 2.2 ohms. If I should range my meter, I want to make this smaller so that you see it clearly. If I should range my meter to resistance mode, when I was talking about voltage earlier on, I was talking about different value of voltage. That the amount of voltage I want to check will determine where I will have my meter ranged. So here, I'm thinking we should stop the class here because it's almost our time. But based on people's opinion, they said we should continue.
Finalize so that come over Kolimo has minutes easily. Come on.
So the conclusion we have here is just to finish up this meter class in a single class. So now I'm waiting for the logouts. Now my multimeter here, I'll place this meter at the resistance range. That is because I'm checking 2.2 ohms here. Resistors should also have different value, ohms, kilo ohms, mega ohms, because there is no value like K or M here. Kilo means kilo ohms, M means mega ohms. Since I don't have any of the two alphabets, it means I'm checking on ohms. Ohms in this meter here, if you check, this 200 here has no value. Which means if I'm to check here, I have, this is 20k, and if I'm to check any resistance above 20k, I'll have to range my meter higher to like 200. And if I'm checking anything below 200, I'll have to come, and below 20k, I'll have to come down within 20k. We have different value of resistor. We have 620k, 1 mega ohms. If I'm to check mega, I'll place it as mega. So the maximum range you can have on motherboard is 2 mega ohms, and I don't even think that one is common. So if I'm to check this, I'll range my meter. This particular one we are checking, I'll range it to this value, 200. And I'll place my probe to across the components, not that ground. So it has no polarity. I will just place it across the component. One part can be here, and the other part will be here. So with this, I will get my value here, 2.2k. So whether the resistor is on the motherboard or not, this is what I will get on this value. So if I'm checking on the motherboard, this is how I'll have it here. So whether it is on the motherboard or not, this is how I'll find it on every other board I'm getting my replacement for. Do you now understand?
Yes. Okay.
So we'll be signed out and everybody will log in again to round off. ABM endurance was in there.
ètò máa ṣí screen mi gan lẹ̀.
So do we now understand this meter part of the board?
Kí èèyàn kan on mic ẹ̀ kó sọ̀rọ̀, ṣé ti mítà tí mo ṣàlàyé yẹn ṣé ó yé everybody? Femlek mo ń gbọ́. Kí èèyàn kan sọ̀rọ̀, má jẹ́ mi nìkan mo ń dá ṣe. ABM, cousin. Now everybody ti wọlé pé padà again. So kéèyàn kan sọ̀rọ̀, ṣé àárín yẹn yé lórí multimeter? Àbí mi ni mi ò gbọ́ yín?
Check my mic.
Kọ́nà kí mi ò gbọ́ yín mọ́ o, èmi ò gbọ́ yín bí nǹkan. Mo dẹ̀ rí mic yín pẹ́ ń sọ̀rọ̀. Femlek. Okay, mo ti ń gbọ́ yín báyìí. Fẹ́ go on ni. ABM náà sọ̀rọ̀ ń sìn yìí. So ṣé gbogbo nǹkan tí mo ṣàlàyé ní àárín yẹn ṣó yé?
Yes, oye.
Okay. Other component tó kù basically tá bá lọ wò from.
So other components, basically if you go and check them from this angle, let me open something else. Okay, let me check the image I used in analyzing this part. Okay, if you check from this angle, we are clear with some section here. For instance, we've explained voltage, ohms, which is a resistor, we've explained diode. So we have these two, capacitor and continuity. So now we are going for capacitor and continuity. So based on that resistance, let me show you one or two resistance more. See, like CLR now, we are saying both adapter voltage and battery voltage meet each other. That component there is a resistor. It is that resistor they call current limit resistor. That is the point where battery voltage and adapter voltage meet each other. If you check the value is always low, around 0.001, but it's not a straight wire. So at times, if you check, we used to have 0 ohm resistor. There is always problem with this 0 ohm resistor. If we are to check them, we place our meter at resistance mode. That is, we should range our meter to the place where we can check resistor. This is the ohm symbol. We have to check 0 ohm, we place it at 200 because anything ohm is not kilo, is not mega. The major problem this resistor used to have is that
Yeah?
I mean,
200. Somebody is asking question difference between kilo and mega. So the difference is that the value is more or less like having 100 naira and 1000 naira. So we're talking about 100 naira and 100,000, they are different. So that's just it. So from low to high, 200, 2000, 20,000, 2 million, thousand, blah blah blah. So now here I'm talking about 0 ohms. I'm talking about the issues this resistor used to have, and the most issue is that where, for instance, we have, for instance, if at this point here, let me find, or let me say, for instance, this resistor, maybe when it is designed, the assigned value here is probably 20k. Yeah, and if it happens that this resistor for one or two reasons the value came down to like 100 ohms. 100 ohms is still smaller than 20, just like talking about 20,000 and 100 naira. Or let me use kilo so you understand. Maybe this value dropped down to 1k, or it increases to like around like 100k. There will definitely be problem with this section. Why? Because the value has been altered. So, and like I've said, and I told you, resistors are used to restrict the flow of electrons that is passing through. So now if we now assign you to resist like 20k, and you are now resisting beyond what is given or below what is given, automatically 100% there will be problem with this section. So the major problem with resistor on motherboard is either it should increase in resistance capacity or it should decrease in resistance capacity. So that is why we need to check their value whenever we are working. So to confirm their value, mostly you get it on the schematic. Initially, at first, when they started their creation, the resistor used to have color code. For instance, you have a resistor here, you have different color like brown, yellow. I know some of you will be familiar with this color. So with this color, they are code to determine what is the value of that resistor. You merge them based on their code, like yellow, brown, black, they have their code. But now everything has been upgraded. We have the SMD. These are very, very tiny, and there is no space whereby they can place those colors. So the only thing you can get to know is only to check them on the schematic. So that is why it is difficult for it and try guys to determine the value of resistance without schematic. So here too we have resistor. They are only connected in part. We'll talk about them. And they have specified function for each of them. So now we are talking about continuity and capacitance. Actually, we don't really check capacitance on motherboard. The major way we check capacitor is we range our meter to diode range. The same way we are checking diode range by placing our red to the ground and positive to supply. The same way of checking our impedance is the same way we check capacitor. So how does capacitor look like on motherboard? We have different type of capacitor on the motherboard. We have those ones that have polarity and those that does not have polarity. For instance, now this is a capacitor here. These ones, they are capacitor and they are being represented with C or PC on motherboard. Capacitor can look familiar to other components like coil. So but the location number here will tell you this is capacitor or this is another component. So here, if you check here, we have how many components here? We have 1, 2, 3, 4. That is, this number 4 is not on the board. This number 4 and number 2. So for this particular component, we carry this number 3. This second one here will be for this. Yeah. With second component we have this number, and this third one we have this, and this last one we have this location. So whenever we are checking on motherboard, at times we might not have the component on the motherboard, but the institution will warrant us to put additional capacitor there. It depends on the fault we are fixing. These two, in this case, these two will be for these two, and these two will also be for these two. Mostly whenever we are checking their value, let me open my meter here. Let me use this one that has probe. So normally this class is supposed to be practical, but for the fact that we are doing this at night, this is 10:30, so we are treating it theoretically. I will try and make practical video for those that need practical videos on this section. So if you are to check capacitor here, one part of the probe will be placed at the ground and the other part will be placed at the supply. In 98% cases where you have capacitor on the board, or let me say 99% cases where you have capacitor on the board, one part will be positive and the other part will be ground. I mean the pattern of connectivity, not the component itself. So if you are to check them, we place our red probe at ground and black probe at the supply. For instance, if it happens that this part of it is the negative part, so if I should place my probe here, red, if I should place my red at ground, let me use red for red. If I should place my red at ground, this is ground, and I place my black probe at my testing point here. So let me do it again. This is my testing point here. So the value I'm having on my meter will determine if this part is clear or not. I can just place the ground at any ground part of the board. Why they call it common ground is because this ground is almost everywhere on the board. In fact, it's everywhere on the board. So on the meter, I shouldn't get value of around 0.02. This is a complete short and this is wrong. But whenever I'm having around like 0.153 digits, blah blah blah, this is right as far as multimeter is concerned. That is that for capacitor. Let me tune it again. Another one again. Okay, you tune this to the diode range. You want to work professionally, but you can still use this, like, or let me say the easy way, the one you find easy. Here you can tune it here. The main point here is I shouldn't get a beep. So the main working principle of this one is anywhere I'm having beep, it's trying to tell me there is connection between those two parts. That is, that if I should use my two probes to touch each other, I will get beep, which means they are touching each other. And the same thing goes with board. If I should place the probe at different parts of the board and I'm getting beep, this is trying to tell me that I have continuity within that line. Like for instance, now if I'm to check destination of wire, whether it's connected or it has been disconnected, I can place my probe at the starting point and place the second probe at the ending point. If I'm not getting the beep, it means the wire has disconnected one way or the other. The continuity itself really means, based on the English word, it means continuity, like something should continue. So let me check if I have data here. This is 1 meter here. If I should range it to continuity range, this is the continuity range here. So if I should place this probe, if I should use this probe to touch each other here, I think this meter battery is low. Let me go for another one. Actually, I'm in my waster here, so I have enough meter. This is my waster.
Yeah, and if I work one day, and again, waster on the day. So, meter you mean look at this place. Look at the range here. If you notice here, you see you have both diode symbol and continuity symbol here. This is because they are working in similar way. Do you see? We have diode range and the continuity range here. They are placed beside each other here because they are working almost the same way. The only difference here is that in diode range, in continuity range, you have beep, and in diode range is not about beep. So aside from that beep, they are working almost the same way. Let me see if this camera will open. Unfortunately, no. So if this meter is placed at this range, continuity range, if I should touch this meter with each other, it should beep. As you can see. If I go for another board here, this is a board here. If I should pick up this board generally, and I've set my meter at continuity, if I should touch anywhere on this board with the second probe of the board, since I've placed the first one on the ground, if I should touch any other ground, I'll have beep sound, because this is trying to tell me they are common ground. So if I'm taking this ground on the board and I'm getting beep, this means resistor come by means pé resistor yìí ó connected mọ́ ground.
This is trying to tell me there is
and the other one
between this resistor and ground. So the other one, that is the same way we check them. Just like I've said, I will make practical video for that part clearly. So do you all understand that section?
Ṣé àárín yẹn
You all understand?
Oh yes, sir.
Okay. Ṣé anywhere?
Is there any unclear part in everything I've explained so far?
Everything ló yé àfọkànbalẹ̀ lọ lẹ́yìn tó wá dọ̀là báyìí káwọn lọ ká lọ gbé mítà ká fi practicalize ẹ̀.
Kẹ́ máa ti bọ́bọ́ ìdójú lọ lókù ẹ̀. But at least ó yé yín clear.
So this person is asking question. Okay. I think he has muted his mic.
Hello, èèyàn kan sọ̀rọ̀.
Well, let's conclude the class before saying any other thing here. So let me check the meter we are using, and we'll check those things we've not talked about as for reading.
Continue, issue of continuity here.
Okay,
Kí ni symbol lórí meter?
òun náà ni ó ní ìlà yìí, symbol ó máa rí bá.
Let me show you the symbol on the meter.
Fáṣí mi jẹ́ mítà yín ló ń dún tí mò ń gbọ́ yìí. Symbol ẹ̀ lélẹ̀. Ṣé ti mo fẹ́ zoom ẹ̀ to the maximum level? Symbol ẹ̀ lélẹ̀ yìí.
Reason why these are placed together, this diode and continuity symbol, because they are working almost the same way. The only difference in the continuity is that you will get a beep sound. Diode will not beep, but you will get a value. Do you all understand?
Yeah. So if continuity gan ló wà gan ní time lẹ́ẹ̀kan yẹn.
Like that diode range, at first if you should start repair, you'll be using continuity because it used to give you beep sound, but by the time you are going deeper on board, you'll be using diode range because that diode range is more accurate than that beeping. Firstly, you will be after if it should beep, you believe there is problem. If there is no beep, there is no problem. Later you will be after the value, whether it beep or it doesn't beep. You will understand. because you'll be after whatever value I have will determine what the section is for. So don't worry, with time you digest it one after the other.
One more question.
Okay.
Concerning the use of coil, tari lẹ́kẹ̀ẹ́. Nípa máa gbé sí diode nígbà tí ò bá wà plugged. What of tó bá wà níbo ló máa wà?
This person is asking if the system is not plugged, where do we have our range? So now let me explain. I said whenever you are checking voltage or current, you have to plug in your adapter. And if you are checking any other thing aside from voltage and current, you don't need to plug in adapter. Another question again.
What assume we are teaching about board.
Okay.
What are the don'ts? That is dangerous. Try that.
This person, the question here is, what are the do and don'ts whenever you are plug your adapter in the motherboard and you are using meter? So I will just explain this in a simple manner. Let me see, wait. When the simple answer is the simple do and the simple don't of using multimeter or motherboard whenever you plug in your charger is you shouldn't make mistake of mistakenly connect where you are not intending to check with where you are trying to check. That is, you mistakenly bridge your board with other supply. That is why it is very, very dangerous if nut falls on your motherboard or you mistakenly couple screw nuts in your motherboard while coupling it, because it will connect unnecessary parts to each other. So the only don't of the multimeter whenever you have your voltage is do not mistakenly connect the parts you are not intending to check with the parts you are checking. So mostly it always occurs when we are trying to check very tiny place. That's why we call it chip level engineering. We check every single pin. We check single pin to know what is the working condition of pin 1, pin 2, pin 3, pin 4, blah blah blah. So in the process of using this, mostly even the meter itself, the probe pin is always bigger than the pin at times, but you can buy better one that is ready made, very tiny pin. And look at this one now. This is pin, this is normal needle. I've attached it to the main rail. Let me show you the original one that came with the meter here. Let me see if I can open this camera. Look at this probe here. You can see the probes pin are bigger than each other. The other smaller one I've used normal pin, normal needle. And look at the main pin for this one here. You can see that's the main probe pin here before me attaching the needle. Because if you are trying to check, you must not bridge in another pin. I can use the two probe, but it always favors to use something tinier. As you can see, just that you have to be very, very careful if you are using bigger probe. That is why at times if you are checking voltage, you don't check them at the pin. Only if we have no option, then we check them. Let me see if I can use pen here. So if you are to check this pin, we don't really check on this pin. Instead, we check if there is alternative. If we should check here now, we have alternative of this resistor. So I can check at this resistor instead of checking at this IC, whereby I will now mistakenly bridge this pin. As you can see, they all have testing parts. It is only those that doesn't have this part will have to go to the pin to confirm. Even this one have separate pad where I can check, or I check on this component. So look at this. This is the part for this one, and you can see some does not have. So we only check at the pin when it has no testing point closer to it. Question.
Oga, you understand the mini question me?
Ṣé ẹ ti get ibẹ̀ yẹn àbí?
I ti get ẹ pa, you understand. So question to me tí mo tún ní ni pé tá bá ṣe observe pé shortage wà pé
This person is asking when there is short on board, how do we detect short? So the answer, the first thing is, how does
happen? How does short work? What is the reaction of board to short? If I should say my board is shorting, if I should say there is short on my board, this meter that I was expecting just 15 minutes. You remember I said in less than, we will finish before our time today. Look at how much time we are consuming on meter. But I'm trying to explain everything clearly. That's the point. So if I should say my board is short, for instance, if I have straight line, let me see. If I have straight line to be my ground part and another part to be my positive part here, let's assume, let's say this supply here. Let's say this supply here, this line is 19 volts, or let me go for something lower. Don't let me talk about only 19. This is another voltage here. This is positive 5 volts here, and this one will be negative part of the board, which is the ground, GND. So we have different components that will be connected to this line, this 5 volt line. Firstly, let me draw one or two components. Let me use another color for components. Let me go for capacitor. This is, when we have capacitor, this is how it will look like. This one is low polarity capacitor. We have diode that is coming from this part as well. I'll carefully explain how they all work one after the other. We should have resistor here again, or let's say we have another capacitor again that has polarity. When we are talking about polarized capacitor, it's always different a bit. Sorry, it's not going to be two straight lines. One will be straight line and the other line will be curve. So this is it here. So let me leave this component like this. Look at all these components here. If you are checking here, you will be getting 5 volts here. So far they are all on the same rail. Here 5 volts, here 5 volts, here 5 volts, and here 5 volts. So if they are connected like this, so whenever you are treating components, you understand them carefully. You understand why they are being connected here. If single one is faulty here, whether this particular one here, this supply part is crossing, let me use ground symbol. If this ground part, this component here is faulty and is now shifting these ground parts to the positive part, what's going to happen here? Every other component connected here will be notifying you problem, and if you check their value, you'll be getting 0.02 at the impedance range on the multimeter. And if it is voltage range as well, all you'll be having there is low voltage, probably 0 volt or 0.1, 0.7, blah blah blah, if not 0.00. So you get 0 volt at the point once it is short. If this is the impedance range, 0.002. So how do you detect which one is faulty among them? Or now we know we have 5 volts in this line, so anywhere I inject 5 volts on this line, any one of the faulty components here will generate more heat. In fact, we generate heat and the rest will not, because this one is because this one has problem here. If it is bridging, automatically they will all be telling you they are all bridging because one is faulty. So the tools you can use to find this easily, we call it DC supply. That is the most simplest one. We will calibrate the voltage down to maximum of 5 volts, since we are dealing with 5 volts here maximum. Once we've calibrated it, the next thing now is we inject the voltage here and reduce the current as well. So you gradually increase the current as you do that. So that is it for this section. Any other question?
Actually, Goga, to understand, man.
Okay.
But about say inject the voltage because you say we come that gbona lot on it, you ma jẹ́ pé o kan ma gbona like inject the voltage. Have you possible, right?
The person said, is it possible that that particular one will be generating it without using DC supply? So actually it's possible, but in most cases you won't get it like that, only if you should force the voltage on it. And look at this place, there is something we call pad whenever we are treating motherboard components. You can easily have the pad any part of the board. Let me say for instance, you can have the pad here, PAD. Let's say that's the pad, PAD. If we should remove this solder, by you removing this solder, it means you have separated this part of the board. So whenever we are treating components, you understand it better. If you should remove this solder pad, it will divide this section of the board. Even this 5 volts, it's going to divide it by separating this 3 component and this single component. I have a practical video, HP folio. I'll upload it, you understand it there. So when after insulating that pad on that practical case I have, let me leave this issue for now. I'll upload the video. So now going back to the class, if I should remove this solder, I've insulated this part. So if the problem is coming from this angle, then I'll be having the problem to be this singular one, and if it is from this other third pad, I'll be having the problem from there. So
to my own observation, mo pe yan ma ní láti ti ra àwọn iṣẹ́ tó tún pẹpẹ ní o. For his
this person is talking about more tools, and I'm telling him one of the major things I like doing is buying. One of the other things I love buying in this repair is buying tools, because tools can easily save my time. At times I used to have single tools in 2 places. In fact, like this now, I have about 3 this in my office, because tools is very, very important whenever we are repairing. So that is it for that part.
Yeah, okay. I understand my oga. Sometimes I read the environment processor at times. Maybe I think I should read. Maybe you come.
So this person is trying to ask question like, why is it that whenever you are reading around the CPU section, those components will be reading short, and if you should remove the CPU, then they will be reading free, like no short. So that is the question he's asking here. So, and if you should remember, I've explained this place earlier on. I guess maybe this person didn't start the class with us. He said he didn't attend yesterday class. I guess that is where he missed this question. So in that previous class, I said whenever you are checking CPU section, if you should remove the onboard chip, the CPU. So if you should remove it, the value will be different. That is, it will read higher. Those chipsets, for the fact that they are on the board, they have series hundreds of components inside them, because they've connected them over and over and over and over. So it affects the value. So that is why whenever you're having processor on motherboard, and you are checking the value of those components connected to that array, you have a very low value. But if you should remove them, if you should remove the processor, then the value will be good. If you should look here, I said with processor, the value can be low, and I'm sure the person is using beep. So the person will say, okay, there is short there because it's beeping. So, and I said without processor here, this is the value, this is the range of the value you will get. I've explained yesterday. I guess this person missed the class. If there is processor on the board, that is the way the readings happen. So let me ask if there is any other question here. Any other question? Okay, actually, your mess online. I guess people are sleeping, yes. But at least we have 9 people online. So I will try and remove some for the meantime. So I will have the expert on board. So from here, since we don't have any question again, we'll have to round up.
adúpẹ́dúpẹ́ gan.
ta ló máa ṣe closing prayer fún wa.
tọ́ adúpẹ́ lọ́wọ́ lọ́wọ́.
ọlọ́ba dúpẹ́ fún.
àmín. ẹ jẹ́ ṣùgbọ́n náà bí kàkà round off.
ó jẹ́
tá a láàfáà ń building ni ẹ ṣe
ó jẹ́
round off nígbà yẹn tẹ́ bá ti ṣe.
àfáwà fídíò ó jẹ́ àfáwà fídíò.
Oje àfáwà
ó yẹ ṣàdúrà fún.
round off ẹ ṣàdúrà ká round off.
ẹ yẹ kí pásítọ̀ Dayọ̀ ṣàdúrà fún adé you for it.
ó jẹ́ àfàlà béèrè.
tọ́ adúpẹ́ lọ́wọ́ lọ́wọ́.
àmín.
alhamdulilah.
ọba tó ní ká bẹ̀rẹ̀ pẹ̀lú ìrọ̀rùn tá a tó yọrí ẹ̀ pẹ̀lú ọlọ́run àdúpẹ́ o. ẹni tí ọlọ́run ló sábà bí iṣẹ́ náà ọlọ́run kọ́ mọ́ ẹ̀kú làákà yín. ọlọ́run tó ọmọ bá gbé yín jà kọ́lọ́mọ́ fà yín sẹ́yìn. fẹsẹ̀ wá ń gbìyànjú pé ẹ̀ ń pass information yẹn tó bá ti ń gbàtọ̀ tó wọlé ọlọ́mọdé gbàtọ̀ ìsìjáde lọ́dọ̀ wa o. pé àwọn afẹ́ ayé get 1 or 2 things kọ́ mọ́ wà fà yín wá sẹ́yìn kọ́lọ́ tó bọ̀ máa gbé yín jà kọ́ mọ́ gbé yín jà. Allah subhana rabbil izzati wa yasifun.
Wassalamu wasalamuna
alhamdulillah rabbil alamin.
èyí wọ gbúrò yín láti jọ yìí.
mo sáà sí mi gan ni.
ẹ wá ti ẹ sá padà báyìí ẹ ti fojú wọn bàbá dáadáa ó dáa.
yóò rọrùn.
àmì.
okay.
hello.
Yep.
Okay, báyà máa sọ̀rọ̀ ní group sá. èmi kàn ní suggestion fẹ́ mú wa ní suggestion lásán ní kí n ṣe lórí ọ̀rọ̀ síra.
okay. kò sí wàhálà.
ní group a máa support and group.
kò sí wàhálà. oya
ayé
fẹ́ gbé bọ́ọ̀dì.
kò sí wàhálà ọlọ́run aṣọ wa.
ó dàrú.
ó dáa.